mind. Now, our sun is taking a lot of blame right now for the ultimate problem. And if you don't think global climate change is the ultimate problem, that's okay. I am going to talk about it for about 10 minutes. So if you need to get up and walk out, meet us at the telescope later, that's all right. Because I know it's not a fun topic. We as human beings really only want to believe what we want to believe in. And I'll give you an example here. This is my youngest son, Ray. And Ray just made it through elementary school. Now he's in junior high. Elementary school, straight A's all the time. I mean, this is a kid that pulls Dad's astronomy books off the shelf, reads through them cover to cover, and we have great dinner table conversation about it. But now that Ray's in junior high, he's not doing so well. He's bringing home a bunch of C's and even some B minuses, and I'm not happy about that. Well, I've thought and felt about it for a little bit, and I've come to the belief that it must be his teacher's fault. That's the only thing that's changed, right? And if I wanted to, I could research this. I could look into it and do an investigation. But what if I find out something that I don't want to believe in? And that might not be a good thing. What if I go to the teacher and I say, hey, are you the reason that Ray's not doing any good grades in school? And she'd probably say to me, no, that's because Ray's goofing off in class. And I'd go to Ray and say, hey, Ray, why are you goofing off in class? And he'd say, well, Dad, it's because I don't understand the material. And I'd say, Ray, you don't understand the material? How come? He says, well, I'm not doing the homework, Dad. And I'd say, Ray, why aren't you doing the homework? He says, well, I get started on it, but then you're like, hey, Ray, come watch Top Gear with me. And that's bedtime. And if I was to investigate that, what I would have found out is that I'm a bad father. That's the last thing in the world I want to believe. So I think it's just easier to blame the teacher. See what I'm saying? I think this is a situation a lot of us find ourselves in as it relates to climate change. Now, the story of climate change, I'm sure you've heard it before, but it's pretty simple. And because it's simple, the solutions aren't impossible. Basically, we've got a very big source of energy from our sun. Some of that energy gets absorbed right into the planet. Some of it gets bounced off into space, especially when it hits white stuff. And this is the concern about ice, glaciers, snow, ice cap, etc., because this light then gets reflected into space. Now, some people will tell you, well, global climate change scenario, it's not going to be that bad because we're going to get more clouds, and clouds are white too. And yes, they are. And during the daytime, clouds will bounce light back into space. But what do clouds also do at night? It's like they trap heat, right? So clouds is by no means a good substitute for ice. The reason why it's so cold tonight is because it's so clear tonight. Later in the week when we're cloudy, we'll go up 10 degrees, even though everything else is staying the same. Okay, well, the light that's emitted, not all of it escapes. Some of it bounces again in the atmosphere and comes back and becomes reabsorbed. And as we add more junk up into our atmosphere, it makes the atmosphere denser, it can store more heat, and it can also bounce more light. So then the concern is, once we start losing that white stuff, the key ice, then we'll end up with even more absorption, and we might end up with a lot faster, yes, we can appreciate it in our own lifetime, observational changes. Well, for a long time, and even now, there are people out there, some of them even scientists, that will say, yeah, but it's the sun's fault, because the sun is the most powerful source of energy. The fancy term here, forcing agent, that's what they talk about in climate change science. Most powerful source of energy. The sun is also getting hotter, and it's natural. If the sun gets hotter, that's natural, so it's okay. There's people like me that say, well, 1970, we as a planet decided that even though smallpox is natural, we don't want it here anymore ever again. And we destroyed it. The entire species, except maybe a couple little vials hiding somewhere in Russia, and maybe a couple up here in northern Utah. Hopefully that's all there is. Now, NASA's been studying the sun for a really long time. Long time before anybody ever heard of anybody called Al Gore. Long time before even President Jimmy Carter said, getting our oil from somewhere else might cause us problems down the road. We should really look into solar panels and other sources of energy. Even before that, NASA has been studying the sun. And one of their most famous missions, at least among rocket science circles, is this little thing called Ulysses. Ulysses was a spectacular success because what they were able to do is they were able to put an object in orbit 90 degrees from the plane of the solar system. Tricky to do. And they were able to then use gravitational assist, all kinds of fancy math, to launch this thing so they could travel over the top of the sun and get an image of the sun at all times, measuring how much energy it's putting out on these very long duration orbits. And here we go with one of these scary NASA-looking graphs. Okay, it's actually not too bad. The thing to key on are the colors. So in green here, we've got the first orbit, one orbit from 1992 to 98, constantly having a look at the sun, except for with Jupiter and other things got in the way. And then the second orbit, or actually they're showing first and the third orbit here, in blue. And what we've got now as we look at these lines, first in green, second in blue, and as you work your way out from the center of the sun picture here, that determines how much energy the sun is giving off. So in 92, 98, when people first start talking about climate change, the sun is giving off a fair amount of energy. And in 2004, 2008, when we start noticing big changes on planet Earth, the sun is producing less energy. And a good scientist would say, yeah, but that's just one line of evidence. You know, we're just going to look at one satellite? No. Actually, NASA, the European Space Agency, has a whole armada of satellites out there that have been monitoring the sun. Now, depending on what kind of sensor system they use, they get a slightly different value. You know, some show 370 watts per meter squared if sunlight reaches planet Earth. Others are a little bit lower. But when you statistically blend all these things together, valid science, valid math, what's been discovered is that since 1978, so now we're back to Jimmy Carter here, the sun has gone through cycles of energy fluctuation consistent with the sunspots, which we assume might be a relationship. And of that entire time, the greatest change in energy was no more than 0.3%. So now we look at what's been observed in a change in energy here on planet Earth. We have, in this time period, had an increase of about 2.4 watts per meter squared, but the most the sun has changed is a tenth of that, 0.24 watts per meter squared. And of course, if we look over here, we can see that our sun is actually getting cooler. Now, as we go into 2009, 10, and even 11, we'll start going up, and our sun will start getting warmer, but don't panic, this little bit isn't going to cause that number to be much worse than it already is. And finally, we can't fix our star, or at least I don't know how. I mean, if you come up with a great idea, please send it, to me. I am the darkranger@gmail.com, and I'll send it to NASA, and we'll save the planet by figuring out how to cool off the sun. But until we figure that one out, we should probably approach things we can solve, and that is taking better care of our atmosphere. Now, when people talk to you about global climate change, they can be tricky about it. They'll ask questions like, global climate change, is that human caused? True or false? And then they'll ask this question, does Mother Nature produce most of the carbon dioxide? And it turns out the answer to both of those questions is in fact true. And then depending on who's talking to you, they'll stop right there. Or they might continue to go and say, so clearly these scientists are crazy. They don't understand their own measurements. Mother Nature produces most of the carbon dioxide, so how can it be humans that are causing global climate change? What they're not explaining to you is the carbon flux cycle, which isn't too hard. I actually have wonderful luck with fourth graders understanding how this works. Basically what we've got is we've got huge amounts of carbon in our atmosphere. Now these units are billions of metric tons. So 760 billion metric tons of carbon in our atmosphere. That seems like a lot, but there's a lot more in the ocean. 38,000 billion metric tons trapped in the world's oceans. And from our forests, as trees and material decay each year, we add to the atmosphere 1.19 billion. This is Mother Nature producing carbon dioxide. But the oceans also contribute a lot of carbon dioxide to the atmosphere. But the neat thing about Mother Nature is that over the course of a complete cycle, 1 year, she also pulls down a lot of that carbon dioxide for new growth, whether it's in the forests or whether it's in the oceans. So when you add these numbers together, you get a nice balance. Now, human beings and our land practices, how we farm, how we manage our forests, we produce 1.6 billion tons of carbon. But interestingly enough, by the way we farm, by the way we manage our land, we actually pull down 2.6. So here, we're cleaning the atmosphere, the way we manage our land. But the big problem is the way we get from here to there and the way we produce our electricity. So 7.2 billion tons of carbon, how much of that do we clean up? 0.0. So when you add these numbers together, yes, Mother Nature, combined together, produces 210.2 billion tons of carbon. Human beings, only 8.8. So clearly it's Mother Nature's fault. Unless you believe in the rule, if you make a mess, you should probably clean it up. Because Mother Nature is actually cleaning up her share and then some. She's sort of helping us with our carbon addiction. Here you go, here's 2.2. I'll help you with that. Even the amount that we end up over here with a +1, we still are just a little bit out of balance. 4 billion tons of carbon each year. Now the good news, methane, which is the next biggest contributor to greenhouse gases, is actually much more cheery. Mother Nature, 0.27 billion metric tons. Humanity produces 0.33. But look at Mother Nature. She cleans up double her mess and just a little bit of ours at the same time. In fact, in the United States, if you have something we can be proud of, we actually, in the last 15 years, had a steady decline in our methane production. So that's good news. And this flux is really small, 0.02 billion metric tons. Okay, so back to the problem here. Now, of course, it's coal, and that's one of the first things we need to get used to. Coal was great because it saved the forests. And at the time of the Roman Empire, 50% of Europe and Asia was forest. By the time we get to the discovery of the New World, 20% of Europe and Asia was forested. If it wasn't for the discovery of coal, we might have lost our forests on the globe eventually. So coal got us out of that problem. It was an excellent solution, but now coal is not going to be the source of solving the next problem. We need to find other ways of getting energy, because coal is the big contributor of all that carbon dioxide. Now, the problem with carbon dioxide is it goes up and down in the oceans and in and out of trees, but it's only completely moved from the system when you make limestone. You make yourself a coral reef or a Bryce Canyon or something like that, and that takes a long time, 100,000 years, to pull carbon dioxide completely out of the system. And then there's methane. And the number one source of methane is livestock, and just to put the record straight, it's methane that comes from this end of the cow, not that end of the cow. Okay? It's a funny joke, but it's just plain wrong. Foregut ruminants put the gases out this end instead of this end. But nevertheless, that's a big source of methane. Also, farming rice is a big source of methane. And methane is a concern, even though there's not a lot of it, because it's a huge molecule and it can store a lot of heat. But the good news about methane is it only stays in the atmosphere about 10 years. So whatever we can reduce in methane is definitely moving us quickly in the right direction. So now it comes down to trade-offs. What are you willing, as a person, as a country, as a planet, to live with and live without to manage this situation? Here's kind of a fun little story. Remember Ranger Patrick, the vegetarian? This is his ride. 16 miles to the gallon, you know, this great big old planet racer, as I call it. And we got in an argument one day, and Patrick says, oh yeah, Poe, let's just measure our carbon footprint. So we sat down. Remember, he's a vegetarian. And what we discovered, my car, which gets 36 miles to the gallon, his car, which gets 16, he could flatten 3 of his tires and drive around at 2.5 miles per gallon, and he actually had a smaller carbon footprint than me, just because he was vegetarian. He's already made some important trade-offs, and it made me shut my mouth. Actually, it made me shut my mouth in particular to one source of food that I miss dearly, and that's beef. I'm off cows for now. Not forever, but for now. Because someday they'll invent a special cow. No, not really. What we can do right now is we can gather up all the silage, all the manure from cows, and some places they're doing this in feedlots, and then collect the methane coming from that, burn the methane to produce electricity to then balance out the carbon budget. So what I'm looking for on the shelf, because I could kill somebody for a hamburger, I'm looking for, under cellophane, nice 2 pounds of hamburger, a little green sticker that says low methane beef. I don't care if it costs me twice as much as the regular stuff. I'll happily eat that and feel like I'm making a good trade-off. But the real solution could actually come from our sun. If we can't blame our sun for global climate change, maybe we can thank it for being potentially part of the solution. And so this is the green energy that everybody's talking about. And when some people talk about this, they'll try to tell you that it's too expensive, it's not that reliable of technology. One of the big concerns is it's too far from where people live. So then you have to build transmission lines to get the electricity. I don't like that argument, because to me it's sort of like saying, I don't want the gold mine because I'd have to build a road to it. Nobody ever said that. So when people talk to you about these kinds of systems and they say they're not reliable or they're too expensive, either they're intentionally trying to mislead you, or maybe they're just not keeping up on current events. Because around the globe there's some really spectacular examples of how this can be a solution to our problem. And just to give you a flavor of that, I've got a little musical montage of some of these systems talking about the amount of energy they produce.